Good morning. I'm going to discuss about the topic state representation in artificial intelligence. In the artificial intelligence, state representation is one of the most important part. That is how to denote the symbols and symbols and objects in the machine learning, machine understandable format. So that is a state representation in AI. Some of the problems are using state representation. That is one of the machineries and cannibal problems. We having the state representation. There are three missionaries and three cannibal wish to cross the river. They have a small boat that will carry up to two people. Everyone can navigate the boat. If at any time the cannibals outnumber the missionaries on either bank of the river, they will eat the missionaries. How can everyone get across the river without the missionaries risking being eaten? This is a state representation. This is initial state. So three missionaries which is mentioned as MMM and the three cannibals which is represented as CCC. Move all the missionaries and cannibals across the river. One of the constraints, missionaries can never be over numbered. அதாவது ஒரு மெஷினரிஸ் வந்து கேனிபிள்ஸோட அதிகமான கவுண்ட்டுக்கு போகக்கூடாது. ஒரு வேளை அந்த கவுண்ட் வந்து ஜாஸ்தியாச்சுன்னு சொன்னால் கேனிபிள்ஸை வந்து மெஷினரிஸை சாப்பிட்ருவாங்க. ஆன் எய்தர் சைட் ஆஃப் ரிவர் ஆர் எய்தர் த மெஷினரிஸ் ஆர் கில். ஆப்ரேஷன் மூவ் போட்டை வந்து லெஃப்ட் சைட் டு ரைட் சைட் அண்ட் தென் ரைட் சைட் டு லெஃப்ட் சைட் வந்து மூவ் பண்ணணும். நெக்ஸ்ட் வந்து திஸ் இஸ் த கிராஃபிக்கல் ரெப்ரசன்டேஷன் ஹவு தே ஆர் மூவிங் லெஃப்ட் சைட் டு ரைட் சைட் வித்தவுட் எனி லாஸ் ஆஃப் மெஷினரிஸ். So this is one of the production rules. OM, that is O is one of the machinery sailing from the boat from left to right. And then M, 0, M is a machinery sailing from right to boat and then 0 is a empty space. And then MM, two machinery sailing from left to right and MM is a two machinery sailing from right to left. CC, two cannibals sailing from left to right and then two cannibals sailing from right to left. One cannibal sailing the boats from left to side, that is O, C, that is one is empty and then one of the cannibal is sailing from the boat left to right. And then C, 0, that is cannibal sailing from right to right and then 0 is a empty space. And then M, C is one machinery and then one cannibal is sailing boat from left to right. And then C, M is a one machinery and one cannibal sailing the boat from right to left. And then we have the solution like this is a game where you must try to solve the problem with the minimum number of attempts. Therefore, all the machineries and the cannibals have crossed the river safely. Then how to representing the state space means how we are identifying the fact. That is the representation which is the symbol of X, and then symbol level moving from one place to another is the representation. And then A equal to B equal to C means which is A is equal to B and then B is equal to C. So then A equal to C is also equal. So equal symbol is using for both all the equals. And then if suppose A plus B plus C is equal to D means A plus B and then A plus they are functioning the addition. So we are using the plus symbol. So we can we are understanding that is we are going to perform the addition process. So next coming to Tower of Hanai, this is also one of the state representation problem. We have three poles and then three items that disk is attached into the stack. The smallest disk is placed on the top and they are on rod. The objective of puzzle is to move the entire stack to another rod. This is the obeying the some such simple rules. They are using poles to move from one end to another end. One disk can be moved at a time. Each move consists of taking the upper disk from one to stack and placing it on top of another stack and placing it on the another stack. That is, a disk can only be moved in the uppermost disk on the stack. No disk may be placed on the top of a smaller one. Next coming to Tower of Hanai using recursion. The idea is to use the helper node to reach the destination using recursion below in the patterns of this problem. Since n-1 disk from A to B by using C, shift last disk from A to C. And then since shift n-1 disk from B to C using A, following the steps below to solve the problem. Create a function Tower of Hanai where pass the n, that is current number of disks, from rod to one rod. Make a function called n-1, that is the disk. Then print the current the disk along with from rod to another rod. Another making a function called from n-1 to disk. Next coming to the time complexity. Time complexity is mentioned as O 2 to the power of n. There are two possibilities of every disk. Therefore, 2 into 2 into 2. That is 2 is 2 into n number of times, so 2 power n. Auxiliary space is a function called stack that is mentioned as O to the O into n. So these are the state space search problem we are representing in AI. Thank you.